Section 5.8, example 2 on page 345, we have sometimes you can simplify radical expressions that contain variables. A variable with an even exponent is a perfect square. A variable with an odd exponent is the product of a perfect square and the variable. For example, n cubed is n squared times n. So the square root of n cubed is the square root of n squared times n. In this lesson, assume that all variables in the radicands represent non-negative numbers. Example 2 says, what is the simplified form of the square root of 54n to the 7th? Anytime you have a number under a radical, you're going to use the factor tree to find the prime factorization. So 54 is even, meaning we can divide by 2, which gives us 27. 27 is divisible by 3, and we have 3 times 9. 9 is 3 times 3. 2 and 3 are both prime, so we can't break these leaves down any further. So instead of square root of 54 n to the 7th, we have the square root of 2 times 3 times 3 times 3. And then since we have n to the 7th, that means we're going to write 7 n's. So if we expand 54 n to the 7th out using the prime factorization of 54 and writing out all the n's, this is what we get under our radical. Again, because we're looking for the square root, we are looking for 2 of a kind. We have 2 3's, 2 n's, followed by 2 more n's, followed by 2 more n's. Remember that a square root is taking anything that's squared, and then you get to take 1 out front. So the square root of 3 squared would be 3. The square root of n squared would be n. Again, n squared becomes n. And finally, n squared becomes n. Inside, we were left with a 2, a 3, and an n that did not have a pair, so they stay under the radical. Now we have 3 times n times n times n on the outside and 2 times 3 times n on the inside. We can go ahead and simplify the inside and the outside. We have 3, and then n times n becomes n cubed. Inside, 2 times 3 is 6, and n. Now, there is a faster way to do this problem. If you notice that there is a 6 times 9 for 54, and you know 9 is a perfect square, you're welcome to jump straight to pulling out a 3 because the square root of 9 is 3. And then you're left over with a 6. Also, you can do the variables quicker than writing them all out. Like the previous slide said, if you have an odd exponent, then we have n to the 6th times n. And when we take the square root, you're basically dividing the exponent by 2. So n to the 6th divided by 2 would give us 3 n's, or n cubed, and then there was an extra n left over inside. I recommend writing it all out because most of them don't take too long. And it's nice to be able to see a visual of where this answer comes from. But if you can do some of these steps in your head, you are welcome to. You don't have to write every single step out. The next few slides have this work written out with some extra explanations. And this was technically a multiple choice problem, so the correct multiple choice answer would be C. Now I would like you to try number 3 on page 345. Simplify each radical expression, the square root of 50t to the 5th power.